Today's topic is instruments in operative dentistry. If you see, the materials used for manufacturing of instruments are originally hand instruments were made up of carbon steel, which is preferred for cutting instruments as it is harder and maintains its sharpness. However, they are more prone to rusting on sterilization. So presently, stainless steel is preferred for most instruments as it is passive and can withstand repeated sterilization cycles. But we have other instruments such as stillite material, which consists of cobalt and chromium, but it is highly resistant to acid and hardness. But in newer technology, we use the nickel chromium instruments, which consist of nickel, chromium, and iron, which is high resistance to degree of temperature. Now we can learn about the classification of instruments given by Marzo. It consists of exploring instruments which helps in illuminating the tooth structure and retraction of the soft tissues and also separation of the hard tissues. Others consist of the removal of the tooth structure, it is by the hand and rotary cutting instruments. Next is the restoration of instruments consists of the condensing, mixing, burnishing, files, carvers, and finishing and polishing instruments. Now we can see the description of various instruments such as the exploring instruments that includes the mouth mirrors. It helps in direct visualization of the field of operation and also helps in illuminating the operating area and the indirect visualization of obscure areas of the mouth. They are available in various sizes such as 2, number 4 and number 5. In that, the 4 and 5 are most commonly used sizes which consist of round in shape. Next are the explorer instruments. These are delicate pointed instruments used for tactile examination consisting of two tips. One is the straight, other is the curved. The straight is bent at right angles to the handles, helps to examine the occlusal surface of the teeth, whereas the curved is like a half moon or exploring tip is at the right angles to the handle. It is also called a shepherd crook explorer. Next is a probe. These are explorers similar to, but they have the primary function in operative dentistry to measure the dimensions of cavity preparations. Now we can see the hand cutting instruments. The hand cutting instruments helps to cleave and plane the enamel and to scoop out the carious dentin. It consists of four parts. One is the handle. The handle of this instrument is straight and contains serrations to provide the better grip. And the shank, which connects the handle and the blade, which is the working end of the instrument. And the blade is the working end of the hand cutting instrument and it is connected to the handle by means of the shank. And the cutting edge is the edge of the blade which produces the cut action of the instrument, and it consists of bevel which helps in direct and the lateral cutting of the tooth. Next is the balancing. Balancing is that in order to cut the hard enamel and dentin using hand instrument, much force has to be generated at the tip of the instrument. At the same time, the instrument should not rotate while it is still in use. So this can be achieved by balancing, that is, by providing the angles in the shank of the instrument. This principle of the instrument design is also called as contra-angling, so that it gives the better access and clear view of the operating site. Now we can see the instrument formula. This was given by G.V. Black, as it is the numerical formula to describe the dimensions of the working end of hand cutting instruments. It consists of the blade width, which denotes the width of the blade expressed in the 1/10 of the millimeter, and the blade length indicate the length of the blade expressed in the millimeters, and the blade angle is represents the angle of the blade relative to the long axis of the handle of the instrument, and the fourth unit is the primary cutting edge angle, which denotes the angle between cutting edge and the long axis of the handle of the instrument. It is expressed in the centigrades. For most of the instrument, the fourth unit is replaced by the second unit in the code. Example is the gingival marginal trimmer. Now we can see the instrument bevel. In that, we have various such as the mesial or the distal bevel. The mesial and the distal bevel, it is just occurred by identifying that the dentist observed the inside of the blade curvature and the primary bevel which is not visible. That instrument is known as the distal bevel. And from the same view, if it is visible, that is the mesial bevel. Now we can see the right and left angled instrument. If the single beveled instruments are usually made in pairs having the bevels on the opposite sides of the blade. To identify where the bevel is, the instrument is held in such a way that the primary cutting edge is faced downwards and pointing away from the operator. Now we'll see different bevels, that is bibevel, triple bevel and the circumferential bevel. The bibeveled instrument is when the blade of an instrument has two bevels on opposing side which meet together to form the cutting edge. Whereas a triple bevel is the blade of an instrument is beveled at the end as well as along its lateral surface. And the circumferentially beveled instrument is the double planed instrument like a spoon excavator. Next we'll discuss about the excavators, which helps in excavating and removing the carious dentin. In that, hatchet excavator is a bibeveled instrument which consists of the same plane as the cutting edge has the long axis of the handle. It helps to sharpen the line angles and to prepare the retentive areas. Next, we can also see the hoe. The instrument has the primary cutting edge of the blade perpendicular to the long axis of the handle. It helps for planing the cavity walls and also forming the line angles. These have the longer and the heavier blades. Next, we can see the spoon excavator. The cutting edge is in the form of a semicircle with an inner concavity and outer convexity, making it resembling a spoon, and also helps in lateral cutting of an tooth. Next, we can even discuss about the chisels. These are the instruments designed after ordinary carpenter tools used for cutting enamel. In that, we have the straight chisel. This instrument is having the straight blade in the line with the shank and the handle. The cutting edge is on the one side only. Next is a mono angle chisel. This is similar to the straight chisel except that the blade is at the angle of the handle. It may be mesially or distally beveled. The other one is a Weddellstes chisel, which resembles a straight chisel and it has a single plane instrument with a bevel on one side of the blade only. It helps for cleaving the undermined enamel. Next, we can see the special types of chisel such as the enamel hatchet. This is a special chisel, has a straight blade which makes it in a single plane instrument. The cutting edge is in a plane parallel to the long axis of the handle. Next, we can see the gingival marginal trimmer, which is a modified enamel hatchet, has the two distinct modifications from the enamel hatchet. In the gingival marginal trimmer, the blade is curved, which makes it a double plane instrument, enhances its lateral scraping action. If we see the instrument formula of the gingival marginal trimmer, it is 10, 85, 6 and 12. 10 is the blade width and the 85 is the primary cutting edge angle and 6 is the blade that is 12 centigrade. If you see how to differentiate between the mesial and the distal bevel, in that in the mesial the cutting edge of this instrument makes an acute angle with the edge of the blade nearer to the handle, whereas in the distal it is farther from the handle. That is, the edge of the blade is farthest from the handle. That's how we can differentiate the mesial and the distal GMT. Next, we'll see the angle former. This is the combination of the chisel and the GMT, modified from a chisel by sharpening the primary cutting edge at an angle to the axis of the blade and the blade of the angle former is beveled on the sides or binding it the three cutting edges, one primary, two secondary cutting edge. This helps in accentuating the line and point angles to create the retentive points. Next, we can see the Weddell stitch chisel. It is the single plane instrument which is having the bevel on one side, and it is also called a special chisel. Helps in cleaving the undermined enamel. It may be mesially or distally beveled. Next, we can see the sharpening of the instrument. The sharpening of the hand instrument is must, or else it will lose their sharp cutting edges because of the repeated contact with the tooth tissues and by frequent sterilization. This can be achieved by the sharpening stones such as stationary sharpening stones, that is aluminum oxide stones or the diamond hones. If you see the principles of the sharpening stones is that it is the instrument should be clean and sterile before sharpening and establish the proper bevel angle, helps to sharpen with a light stroke or the pressure, and remove as little as metal from the blade as possible after sharpening, and remove all the metal cuttings from the sharpening stone and re-sterilize the sharpening instruments. And coming to the rotary cutting equipments, these rotary cutting instruments have been evolved from the hand rotated instruments to the contemporary A turbine instruments from 1700 to 1994, from 300 rpm to 3 lakh rpm. If you see the speed ranges of it, the slow speed includes the below 12,000 rpm, helps in removing the caries. If you see the medium speed instruments such as the 12,000 to 2 lakh rpm helps in cavity preparation and also has limited visibility. Next are the high speed instruments which is over the 2 lakh rpm, helps in removing the old restoration and also completing the most of the cavity preparations and tooth reduction for crown preparations. That's how they are important. Now we'll discuss about the hand pieces. It is a device that holds and transmits the power to the rotating instrument. In that we have the straight hand piece. Here the long axis of the burr is the same as the long axis of the hand piece, and it is more frequently used for laboratory work. Next, we can see the contra-angled handpiece. This is the primary handpiece used in the mouth. The head of the handpiece is the first angled away from and then back toward the long axis of the handle. This is also one of the handpiece used frequently. In this contra-angle, we have the micromotor and the erotor handpiece. The erotor handpieces are connected to the air water line of the dental unit and can be activated by compressed air supplying by the compressor. If the speed range is 2 lakh rpm of it.